Alright, this is going to be a video about the parent functions. Now when we do parent functions, we're talking about functions. And a function is going to be a relationship between x and y. So you're usually going to have some letter, let's call it f, and f is going to be a function. Now what it's going to do is it's going to take an input like x and it's going to map it to an output called y. And what we do is we call x the independent variable. And we call y the dependent variable. And that's because y is dependent on what x is. Okay? So that's the difference between independent and a dependent variable. Now what's going to happen is you can usually write a function as y equals f of x. So we're going to look at the first parent function that I have right here, the constant function. And do know that the definition of a parent function is over here. A parent function is going to be the simplest form of a family of functions. And you'll understand what that means a little bit later. So the constant function is the first function that we're going to look at. The way you write the constant function is f of x equals c, where c is a real number. C has to be a real number. So the way this is going to be graphed is you're going to get a horizontal line. What I'm going to do is I'm going to draw a horizontal line at 2. And I should probably change to black. There we go. And I'm going to draw this horizontal line right here. And I'm going to put arrows on the ends. So this is the constant function, and it's always going to be a horizontal line. A horizontal line. Now since it's a horizontal line, it has a slope of 0. It has a slope of 0. And it's important to know that c is just going to be a real number. Okay? So that's the constant function. The next function we're going to look at is the linear function. Now this is where it gets a little bit more interesting. The way you write the linear function is f of x equals x. So what's this going to look like? Well, this is going to be a line. It's going to be a line through the origin. So I'm going to have a point at 0, 0. And then any point really that has the same x and the same y coordinate, so let's say 1 and 1, 2 and 2, what I'm going to do is I'm going to draw a straight line through all 3 of these points. Straight as I can. And I put arrows at the ends. So that is f of x equals x. When you graph the linear function, you're going to get a line. And that's what linear means. You can see the word line comes straight from that. And that is f of x equals x. Not much more to say about that. The slope of this line is always going to be the number in front of x. So if you have y equals mx plus b, remember that the m is going to be the slope and the b is going to be the y-intercept. In this case, the y-intercept is 0 because it crosses at 0, and the slope for this is going to be 1, at least for this particular function. So that's the linear function. You're going to get a line. Now the next function that we're going to talk about is the quadratic function. It's going to be f of x equals x squared. And when you graph it, you're going to get what's called a parabola. And sometimes you'll hear this called a U-shape. So here's what it's going to look like. And if you've ever graphed y equals x squared before, you know what it's going to look like. There's going to be a point here at 0, 0. There's going to be a point at 1, 1, and negative 1, 1, and then 2, 4, and negative 2, 4. So that when you connect all the points, you're going to get this smooth U-shape. So y equals x squared, or f of x equals x squared, is always going to be a u-shape. Okay, next function we're going to talk about is the cubic function. The cubic function is going to be f of x equals x cubed. F of x equals x cubed. The highest exponent is 3. That's why we call it a cubic function. And if you've ever graphed it before, you know what it looks like. You're going to have a point at 0, 0, 1, 1, negative 1, negative 1, and then 2, 8, which would be off this graph up here. And you would have negative 2, negative 8, which would totally be off the graph. But it's going to look like this. That's the cubic function. Okay, so that's f of x equals x cubed. That's called the cubic function. The next function we're going to look at is called the absolute value function. And the way you're going to write this is f of x equals the absolute value of x. So you probably worked with absolute value before when we did absolute value equations and inequalities. Now when you graph this, you're going to get a V-shape. You're going to get a V-shape. So instead of the quadratic function where you get a U-shape, the absolute value function is actually going to give you a V-shape. So you're going to have a point at 0, 0, 1, 1, negative 1, 1, and then 2, positive 2, negative 2, 2, and then you're going to get this V-shape. And the V-shape is going to go through the origin. Okay, so that's the absolute value function. The next function we're going to talk about is the square root function. Now the square root function, it's going to be exactly as you see it, square root, so it's going to be f of x equals square root of x. This is also called a radical function. Sometimes you'll hear it called a radical function. And it's just square root of x. Now when you graph it, this is the one where it actually looks like a sideways parabola. So you're going to have a point at 0, 0, that's where you start, and then you're going to have a point at 1, 1, and then you're going to have a point at 4, 2, which would be right here. And then I connect all the dots like this. It's going to be a smooth curve going to the right. So we start at 0 and we go to the right. This is called the square root function. Now let's talk about something that's related to the square root function, the cube root function. So the cube root function is going to be written like this. The formula is going to be f of x equals the cube root of x. So the cube root of x is also a type of radical function because it has a radical, the cube root. So this is also a radical function. Now this is going to behave kind of like the square root function, but it's also got a little extra to it. You're going to have a point at 0, 0, as always. Then you're going to have a point at 1, 1. And you're going to have a point at 8, 2, which is off the graph. You're going to have a point at negative 1, negative 1, right here. And then you're going to have a point at negative 8, negative 2, which is also off the graph. So your function is going to kind of look like this, with arrows at the ends. So see how you have the square root function, but then you kind of reflect it and it goes to the left? This is going to be called the cube root function. Okay, and we have 3 more functions to go. This one is called the reciprocal function. The way you're going to write it is f of x equals 1 over x, 1 over x, where x can never be 0 because you'd be dividing by 0 at that point. So we have 1 over x, and the way it's going to be graphed is it's going to be graphed like this. You're going to have a part of the graph that goes like this. You're going to have a curve up in this quadrant, and then you're going to have a curve in this quadrant. Now the interesting thing about this graph is that it does have asymptotes. it does have asymptotes. And asymptotes are these dotted lines. They're kind of like imaginary lines where the graph can't cross. So you're going to have an asymptote at x equals 0 and y equals 0. So the graph is never going to touch the y-axis or the x-axis. Okay, so that's the reciprocal function. It's always going to be in those two parts. Okay, now we're getting to a function that you've probably never seen before, but now is as good a time as any to introduce it. This is called the exponential function. The exponential function is going to be written like this. You're going to have f of x equals a to the x power, where a cannot be equal to 0. A cannot be equal to 0. So this is called the exponential function. What it's going to look like is it's going to look like this. It's going to be one piece. It's going to be a gentle curve. It's going to be looking like that. And actually, let me do that again. It's actually going to go through the point 0, 1. So it's actually going to look more like this. This is called the exponential function. Now, it is a graph that's in one piece, so there's no two pieces. And the interesting thing about this is it also has an asymptote, just like the last one. The asymptote is y equals 0, otherwise known as the x-axis. So the graph is never going to cross the x-axis. Never crosses the x-axis. Okay? Now, a really good example of the exponential function is 2 to the x power. So imagine you have a function g of x equals 2 to the x power. If you let x be something, let's see what y equals. So I'm going to make a chart, x and y. If x is 1, then I'm taking 2 to the 1 power, which would just be 2. If I let x be 2, then I'm taking 2 to the second power, which would be 4. And then if I let x be 3, I'm going to get 2 cubed, which is 8. So it's going to get exponentially larger. And in fact, this is called exponential growth. Exponential growth. Now, if your graph looks like this, on the other hand, going down like that, that's called exponential decay. Exponential decay. Okay. And then the last one that you haven't seen before is called the logarithmic function. So the logarithmic function is going to be f of x equals log base b of x, where b has to be greater than 0. Okay, so the important thing to know about this is b is called the base. B is called the base. And the base has to be greater than 0. That's the only rule about it. So one of the interesting ways that you can write out the logarithmic function, let's say you have an example where b is 10. Then you would have g of x equals log 10 of x. So b can be any number that's bigger than 0. Just know that. So the way this is graphed is you're going to have a vertical asymptote. You're going to have your vertical asymptote at x equals 0. So it's going to look like this. And it's just going to go that way. But over here, it gets really, really close to the y-axis, but it never crosses. So this is going to have an asymptote. The asymptote is x equals 0, also known as the y-axis. Okay, so that's all 10 parent functions. When you get to your classwork, you're going to have to identify the parent function by looking at the graph. So you're going to have to match the graph to the parent function. And you'll also have to identify the parent function by looking at the formula. So I might give you g of x equals log 10 base 10 of x. And you would have to tell me, yeah, that's the logarithmic function. I know that. So you have to identify them by graph, but you also have to identify them by formula. And we'll be looking at that a little bit later.